Like I said, today we're just going to work through these problems on the packet for notes. So nothing new in here, just applications of derivatives like we've been doing for equations of tangent lines and things like that. Also, the problems that I picked here are ones that will help you review chain rule, quotient rule, and some of the derivative skills that you need to be good at for our quiz on Wednesday. I even wrote the homework up there on top of the page for you, so that's all taken care of. So for the first type of problem, we're finding equations of tangent lines. And we just did this in the warm-up. We did it last class. So this is just more practice. And here's an equation, x plus 1 over 2x minus 3. And I want to find the tangent line at 2, 3. Well, a straight line equation is always y minus y1 equals m x minus x1. As long as we can fill in the constants here, we've got an equation. Now, out of these constants, I already know x1 and y1, right? What are they? 2 and 3. Yeah, exactly. So x1 is 2, y1 is 3, but I don't know m. Oh, that is an x. It didn't. It's not very neat. Thank you. But m is just the derivative, right? So if I just find f prime and plug in the x value. So m is f prime of 2, because that's the x value where I'm taking the derivative. So I just need to find f prime. So f prime is quotient rule for this one. I don't see anything that factors or simplifies. So bottom times derivative of the top minus the top derivative of the bottom over the denominator squared. Oh, okay, yeah, we're not, that's only, you only have to do that for implicit derivatives. Right? You can do that here, but basically you just have a dx and a dx and a dx, and so everything would just be dx. So it would all, you'd just end up with just a big dx at the end. Now this needs to be simplified, and you know, if you need to be really careful here because you make mistakes, you can certainly just distribute this whole thing out and take an extra step. Because it's pretty common to make a little mistake here. And now we see what cancels out. The two x's cancel out. So my derivative is negative 5 over 2x minus 3 squared. No, there shouldn't be. Thank you. I don't know. I have no idea. There. Thank you. Sorry. It happens. And in terms of simplification, you know, on next week's quiz, I would expect you to turn this into that, because that's, you know, not only is it easy, but it really simplifies the problem. So make sure you simplify quotient rule that far. Now I just need to find what f prime actually is, because I need to know f prime of 2. So I just plug 2 into that thing, and I'll get negative 5 over 1 squared, which is negative 5. So for my final step, that's the missing piece in the equation of my line, because that's what I'm trying to find, is the equation of the tangent line at this point. So the equation of the tangent line is y minus 3 is negative 5 x minus 2. And I'm always happy with point slope form. So you can leave it like that. Any questions at all on that? So we started with the equation of a line, plugged in what we knew. We saw we were still missing the slope. Slope is the first derivative, so I computed it, plugged in the x value, and we're done. The next two problems are the same. It's just basically different kinds of derivatives I wanted you to practice. So for the next one, I'll write it up on the board, but go ahead and take the first derivative there. And try to see if you can do it without the quotient rule. I think it's easier if you don't use quotient rule. You can do it that way, but it's... And that's how I'd write it if I wanted to avoid the quotient rule. I'd make that denominator to the -1. And that's what the derivative looks like after you do the chain rule and then a little simplification step.
Are you going to want us to take the negative exponent to the bottom?
Yeah, I'd like you to start getting the habit of doing that. Again, it's a pretty easy simplification step that I think we can all do now that you're really comfortable with the derivatives. It's exactly like what we were doing with implicit. It's just these are explicit equations, so we don't have to take an implicit derivative. Yeah. Any questions on the derivative? All right, so now we can find the equation of the line. I need to know f prime. Where do I need to know f prime at? What x value? -1, because that's where I care about the slope. So f prime of -1 is just going to be -9 over -5 squared, which is -9/25, and that's the slope. So that means the equation of my tangent line is y plus 3/5 equals -9/25 x plus 1. And we're done. Any questions? Now the next one, same instructions is right on the top of the next page. And do the same thing. Find that derivative first. I'll put it up on the board. You should rewrite each of those as powers, x to a power and cosine x to a power. Then you can use the power rule and the chain rule to find that first derivative.
What is the point for that one?
I'll write it on the board. I forgot to put it in the notes. So rewrite those with exponents so you can use the power rule. That's the easiest way to take this derivative. And then simplify your answer, and then we'll find the value together. I'd write it x to the -1 and cosine x to the 1/2. And on that cosine, you're still going to need chain rule.
The point?
It's on the board, pi over 2, 2 over pi. It's still cosine on the
Still
inside.
cosine?
And then you do chain rule.
It's the, oh.
That's the first step of my derivative up here. Negative x to the -2 from the power rule. And then 1/2 cosine to the -1/2 from the power rule. But since there's a nested function here, there's a cosine inside of the square root, I have to do chain rule. So I multiply by negative sign. You cannot change the cosine to a negative sign. It's not because of the x. It's just because when you apply the power rule, the inside doesn't change. The inside stays the same. Then you multiply it by the derivative. Now I want to simplify this again, just getting rid of the negative powers. So it's -1 over x squared. And then this next one will be sine x over 2 square root of cosine x. And again, this is the kind of simplification I'd like you to start doing on all your problems now, if it applies. Again, it's just getting rid of the negative and the fractional exponents. So it should be easy. Now, next thing to do is plug in the point, but I want to make sure if there's any questions on the derivative. All right, so the point is pi over 2, 2 over pi. So I need to know what f prime of pi over 2 is. Which means you need to know sine and cosine of pi over 2. You may want to remember the unit circle. Cosine is x, sine is y, so find that point. The point's going to be 0, 1. So cosine is 0 and sine is 1, exactly. Which, what does that make my slope? Undefined, right. So the slope here is undefined. What kind of line, what kind of straight line has an undefined slope? Straight up and down. So at this point, all we know is that this may either be a straight up and down line, or there may not be any tangent line at all. And we can't tell just from doing this. We'll see that in a couple weeks, how to tell if there's no tangent line at all, or if it's straight up and down. So for here, we'll just say slope is undefined, and we're done. It turns out this graph if you look at the square root of cosine x, that's going to look something like that, where it comes to a really sharp point. And we'll see in a couple classes, if you have a graph that comes to a really sharp point like that, you don't have a derivative there at all, because you can't have a derivative when it's a sharp point. Questions on that one? Okay. The next couple problems also involve taking derivatives, but now the question I want to answer is, you're finding where the tangent line is horizontal, so I'm not giving you a point. You're figuring out what the point is. Okay, so the slope of a horizontal line is 0. So once we find the first derivative, once I know f prime of x, what do I have to do? Set it equal to 0 and solve. Exactly. And we'll solve for x. So that's what we'll do in these two problems. The first one, derivative's really easy to take. So where is the tangent line horizontal? And the first one is 3x squared plus 2x minus 1. So all together now, what's the derivative? 6x plus 2. Perfect. Y prime, yep, is 6x plus 2. You know what? I guess in the notes I called it f of x. So yeah, f prime. Sure, yeah. So where does this thing equal 0? Bingo, you got it, because I just have to set that equal to 0 and solve. So x is negative 1/3. Now that's the x value where this has a horizontal tangent. So my answer is negative 1/3 comma something. And right now, what do I need to do? Plug it in. And where do I plug it in? Into y or y prime? The original. Into the original. Because I want to know the point on the actual graph. So it's got to go into the original equation. So f of negative 1/3 is 3 times 1/9 minus 2/3 minus 1. Which is 1/3 minus 2/3 minus 3/3, which is negative 4/3. I believe. You're finding the coordinates, exactly. Now, if I didn't ask you to graph this, but this one's actually easy. I mean, this is a parabola, right? So, you know, it looks something like that. What is this point on the parabola? How would you describe where that point is? Yeah, it's that vertex point right there. Horizontal tangent line is going to happen at the lowest point on a parabola. So that's the point that we found. For the next one, do what we did before. Find the derivative yourself. I'll put it up on the board. And then we'll find where the tangent line is horizontal. I would probably just use quotient rule on this one instead of trying to make it a -1, but either way would work. first step is up there, and then you'll want to simplify after that.
It's g of f prime minus f of g prime over g squared. And then product rule, does it matter like f of g prime first or g of f prime first?
Because it's plus, so it doesn't matter. Yeah, there's no point. You're finding the point for this one. There's my derivative on the board. Any questions at all about this? Okay, now I need to set this equal to 0, right? So this has to equal 0. Yeah, this may look really complicated, but remember, yeah, I mean, all I care about is that the numerator equals 0. Right? As long as the numerator is 0, who cares what the denominator is? So this is the same as solving negative 4x squared plus 24 is 0. You can also think of that as cross multiplying, and the denominator cancels out. If that makes sense, think of it that way. Well, because if the top equals 0, I don't care what the bottom is. Exactly. Exactly. And that's a really common trick with these kinds of derivatives. And now this is easy to solve. X squared ends up being 6, so x is, just like in the warm-up, 2 answers, plus or minus root 6. So that's where the slope is 0. Now I just need to find y, and I have to plug in 2 different x's, because they'll give me 2 different y's in general. Say that again? One the answer. Oh, no. Because, are you thinking, but that's a plus 6. Yeah, but it's a plus 6, so it doesn't cancel out. Right. Yeah. When I plug root 6 into here, I want to get 4 root 6 over 12. Make sure you verify that. And what does this simplify to? Yeah, root 6 over 3. And f of the other point, negative root 6. Well, if I plug in a negative root 6 here, the only thing that changes is the minus sign, right? Because the squared is still positive. So that's just going to be negative root 6 over 3. So that makes my 2 points. Root 6 comma root 6 over 3. And negative root 6 over 3. This graph, it's not so obvious just from looking at it what the shape is, but it turns out that it's kind of flat and then sort of comes up, something kind of like that. So it has a little horizontal tangent there and one there.
So you'd have 2 equations for tangent.
Yep, you'd have, if I asked you to write the equation here, there'd be 2 different equations for 2 different tangent lines. One of them would be y equals root 6 over 3. The other one would be y equals negative root 6 over 3. Yeah. Questions on that one? Okay, 2 more on the back, or on the next page, I mean. Another application of tangent lines, asked a little bit differently, but it's a very similar question. I need to know when the tangent line to a certain equation is parallel to a certain line. So what do I have to do in this case? If the tangent line is parallel to some other line.
Set the derivatives of both equations equal to each other?
Almost. I don't need to take the well, okay, actually that actually would work because the tangent line derivative, what do I get if I take the derivative of just a straight line? You get the slope, right? The derivative of a line is just its slope. So by setting the two derivatives equal to each other, that's saying the same thing as I set the derivative equal to the slope of the other line. Right? So I'll get some numbers on the board and we'll see what that looks like. But if I want the slope to be parallel, I set them equal. So where is the tangent line parallel to 2y plus x equals 6? And the first one is x plus 1 over x minus 1. Okay, so first thing I need to do is actually know what the slope of the tangent of this line is. Yeah, -1/2, right. And you can just write it in, you can write it in standard form if you want or whatever, but slope is -1/2. Right. So I need to take the derivative of this thing, and instead of setting it equal to 0 like we just did, we'll set it equal to -1/2 and find that x value. That's perpendicular. Perpendicular is negative reciprocal. And we'll do those kind of problems too.
Parallel is the same slope.
Parallel is the same slope. Exactly. I'll work out the derivative up here. You can do it on your own if you want. I'm just doing quotient rule. Be really careful with simplifying these quotient rules because there's a lot of terms up there that you can make one sign mistake and your answer is completely wrong. Any questions about the derivative? So now what do I do with that -2 over x minus 1 squared? Set it equal to -1/2 and solve. So I'm going to set it equal to -1/2 and solve. So like that. And whenever you have two rational expressions, the easiest thing to do is just cross multiply. So if I do that, I get -4 is negative x minus 1 squared. Get rid of the negatives. Take a square root. Just like in our warm-up, there's two solutions. X is 1 plus or minus 2, which means 3 or -1.
You just canceled out the two negatives.
Here, from there to there, yeah, I did. So now plug those in and find the y values. I mean, once you're happy with this number, find what the y values are for those two. And if you have any questions about that derivative, just let me know. Answers on the board.
That's what I'm supposed to do.
1 plus 2, 1 minus 2.
Where did you plug back in the x values when you found them? You didn't plug them back in the original?
I did plug him back in the original.
Not that one. Oh,
Right. Because the y values are on f. They're not on f prime.
So isn't it 2 and 0?
yeah, it is true. It's when you just wrote.
2 and
Yeah.
0. So the first point is 3 comma 2, and then negative 1 comma 0.
Where did you get 3?
Those are the
the
X's.
x values.
Yeah,
Oh,
then you
yeah,
make
yeah, yeah.
hard-
Right? Because I'm given coordinates x comma y. So we found the slope of the line, not a tangent line, just the slope of this random line that they gave us. I found the slope of this thing first, took a derivative and set it equal to that, because the derivative gives me the slope of the tangent line. Once I found my two x values, I plugged them back into the original equation and get the two y values. Any questions? Okay, last one in the packet is a cube root. Take that derivative and try to do the whole problem. I'll start it on the board over on the other side. It's going to be another power rule and chain rule to take that derivative. You mean the coefficient is going to be, well, let me come look at your, who asked, was, okay, let me come look at your paper.
I have to set it to negative.
Set it equal to negative 1/2, right.
Oh, but since it's a 3, isn't it a 1/3?
It's 1/3, right? The power is 1/3. Yeah,
It's the same like first.
right.
It's if something's there that.
Exactly.
Oh, set it to that. Oh, sorry, I thought you were saying like make like addition inside. Yeah.
That's how I'd write it, with a 1/3 power.
I'm confused. How do you? This is just algebra, but like, how are you gonna? What's the easiest way to simplify this step? Like,
Oh, you mean to go from there to there?
Yeah.
To,
do I like take
Well-
the cube root of like 3 and square that or whatever?
yeah, so to cancel out any power, right? Anytime you have a power, you just raise both sides to the reciprocal. So I'm going to raise both sides to the negative 3/2. Because 3/2 times 2/3 is 1.
Okay. So,
So-
that cancels out that and then that. So
Exactly.
you raise that side to the reciprocal.
Uh-huh.
Okay.
Uh-huh. Right.
3 halves.
Right.
I can just do that on my calculator.
Yeah. Anytime you have a power, you can raise both sides to the reciprocal power.
So then that would get rid of this and negative 2 you raised to 3 or 2.
Exactly. The derivative here is 1/3 3x plus 4 to the negative 2/3 times 3 from the chain rule. Okay. If I write this in a more without the negative exponents, I get that. And I want this to equal negative 1/2.
Really, I don't like this. Wait, you say you don't get it?
Now, if I do I can either do a cross multiplication step here, or you can think of it as setting the denominators equal to each other because the numerators are both 1. But your next equation you can get from this is negative 2 equals 3x plus 4 to the 2/3. Because my slope is negative 1/2 over there. So this is negative.
Isn't it 3 over 2 cube root of 3x plus 4?
When this 1/3 turns into a 1/3 right there, and that cancels out the 3.
Oh, I don't know why I put a 2 at the bottom. Yeah.
Any other questions up to that point? Now, the big question is, do you remember how to get rid of a 2/3 power? Yeah, and what power will cancel out a 2/3? 3/2. Right, I take the reciprocal and I raise both sides to that power, because 3/2 is going to cancel out the 2/3. So that gives me negative 2 to the 3/2 is 3x plus 4. And the good news is that we're done, because this is no solution. Why is it no solution? Yeah, there's no calculators, remember? They don't work. What about this? Negative 2 to the 1/2. What does that mean? Square root of negative 2, right? You can't take a square root of a negative number. This is the square root of negative 2, just cubed, right? So this is still no solution. You can't take an even root of a negative number. So however this fraction looks like, if that bottom number is even, right, you can't take an even root of a negative number without using imaginaries. And we don't care for imaginaries because this is just defined. We're just looking at real numbers. So no solution means there's no place where this has a slope of negative 1/2. And if you think about the graph, cube root of 3x plus 4, no, it's some kind of cube root graph. I guess the slope never equals, well, if you look at this, kind of graph, the slope here is always positive because cube root is always increasing, right? Cube root starts down here and it's negative and it just goes up, 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 up. So cube root always has a positive slope, so it can never equal negative 1/2. So no solution to this problem. Questions? All right, we're done.